Hello guys, Gennady here. Welcome back to ABPKit Dev series, a series in which I share how ABPKit is developed. Today we will complete the implementation of the component responsible for loading from the bundle, at least I hope we'll do, and let's first do a quick recap on what we have achieved so far and what we will try to conclude in this episode. So far we have implemented the main use cases for this BundleLoader, and those are expressed in our tests, and we can go fast through them. First thing first, we test that if the file does not exist for a given source, then we complete with error. Then we test a custom source that client can specify to be used to load from the bundle. And then we have tested all of the possible currently available ABP filter lists, and at the same time we have refactored our code in such a way that it will be easy for us to support new filter lists. That being said, if we add some new filter list here, it will be easy list, I know, Russian or something like this, then we will just copy this part and paste, and then we will have straight away a test case for our new source. So as you can see, the main feature for this component is to load a filter list from bundle for a given source, and we have already tested this. But of course there are some things to improve, and first thing first is this try bang here that we will crash in case we can't actually extract the string from the file. And then we should think of, should we have this encapsulating class called BundleLoader around the bundle? Maybe we can create an extension over the bundle that will implement this bundle filter list loader, and therefore we don't have yet another component. And yeah, we should look into this and see what are the applications. So let's start straight away with this ugly try bang. And yeah, as always, when you see this sign, this is a sign of trouble. So let's think a little bit of what could go wrong here. One first thing that we might think of is, well, if the file does not exist that is given path, then this should fail. But actually we are already covered by this. We have even a test. If the file for sure does not exist, we complete with error, which means that we are already covered by this scenario, and gladly we have this util function on bundle that provides always an if the file exists, will provide for sure a good file path. So this can be a reason for this to fail. So what could be other reasons? Well, when we extract from the file, we should have a given encoding for a string. And that means in which way we can decode the data from the file to a string. And this is, I guess, the most probable case that this extraction from the file could fail. So we should, in a way, test if we have a corrupted filter list JSON with some bogus data, God knows what we'll put there, and test that we throw a failure if the file is corrupted, and we shouldn't crash. At least, well, we don't necessarily care about the what error and so on. The main point is that we shouldn't crash. So let's start with a test and express what we want. So we'll say test load, and here we'll have a corrupted filter list throws an error, or maybe we should call it complete with error to be in the same fashion as with other test cases written above here, complete with error. So what setup will we need for this test? Well, I guess we should need something like this. Yes, and here we should have a corrupted filter list. Yes, and we should complete with failure. And of course, right now, I guess these tests will pass already because we throw an error if the file does not exist. And indeed, we don't have this file, so to say. And let's look at what will be the content of such file. So here I have already a file, and the content looks rather interesting. I don't know what is this in terms of the text, but actually if we transform it to what it was originally, and let's see, this is actually an image, and yeah, this is the logo of the SwiftDev YouTube channel. So basically I tried to find the possible corrupted filter list JSON. So I've got this image and then converted it to JSON, and indeed I got this very nice looking string. So let's see, we have here corrupted filter list. Let's see that the names match for those two. Now we are sure this match, and of course we should remove the JSON from here because we already check for the type of it. And yeah, I guess we should crash here. Yes, indeed, we crashed here, and as we can see, the error says that the encoding of the content can be determined because we did quite a good job of having some, I don't know, unreasonable string here. So yes, we should handle this, and let's do the most simple thing that we can do is to get this from here and bring it up top, and basically transform this try to be an optional. So basically if this will fail, then it will return nil, and our guard statement will redirect the execution to the else part. Basically we will throw the load error, but if this is not nil, then we will complete. And let's see if this did the job. Yes. So this is one specific case for us, is that we get the string from the file. So we actually need to determine in which way this can fail. But if we would want to extract something different from the file, let's say that we will have actually some custom data, some struct representing this JSON object, then of course we will transform to the JSON object. So then we should assert that we can transform the content of file to the given model, and in our case the model is string. So we have provided some test case in which converting the file to the string model fails, but if you have some different model, let's say some model like a user model, or as I said currently blocking rule model, then I guess in the file you just put some string that cannot be converted to the model, and this is already a good case when you have a malformed JSON. And for us right now the malformed JSON is something like this, because we don't yet assert the structure of the file, but we will discuss this in later videos why we are not doing so. So yeah, this will assure that we are covered in case that we can extract the string from the file. I don't know, something like this, that we cannot build a meaningful Swift string. And yeah, of course, this is good here. We throw an error, but maybe we'll want to forward the error of this try, so we can have a more meaningful error thrown. So let's do this. So we'll have a usual try catch, and let's remove it from here, and actually this should be moved here. We can have this like this, and then of course we will catch the error and complete. Good. We should actually here complete with failure, of course, because we have failed to extract the string and we have the error. Let's run our tests and see that we are still good. Yes, we are good, but here I think we can refactor still further. We have one completion here and one completion here, and also do catch. It is looks somewhat verbose, and maybe we can write this in one line. Let's see how can we do this. Well, let's do it step by step. I think first we can get this from here and put it here. You can argue that this does not necessarily look better because you have completion, success, try, string, contents of file. It's somewhat convoluted one-liner, but then we can do one more step further, and that will be what if we have the just completion, and inside we determine what will be the result of execution. And with this we can make use of the result constructor with a closure that throws. So here we have the closure, and then we just can bring the code that throws, put it here, and then we can put it in one liner, and basically we complete here with the result of this operation. Let's run our tests and see that we are good. Yes, we are good. Let's see if we can take a look inside the result. And do we have here an initializer? Let me check, just for the sake of exemplifying. Yeah, for the moment I think I'm missing it here. Let's see, yes. So we have this initializer with the body of a closure that throws. So yes, you can make use of this to write some nice code, one-liners or something like this one. You just complete straight away with the result, and what we execute you put in this catching body. Indeed, a nice feature of a result type to have. So good, we have also implemented this case if we have some corrupted file, and and we are good with this. The next step will be to think of, do we need this encapsulating class BundleLoader over the bundle? And maybe we can have some generic behavior that can be reused to load any data from the bundle, because at the end of the day we might end up with having multiple features that want to load from the bundle, and we will have a lot of duplicated code. This will be one of the cases for sure, and so on. So maybe we can have some generic functionality that loads from the bundle, and then we can have extensions for specific protocols that will transform or map the data to a given format. So let's try and do so. First thing, what we will want to do is, I guess, to extract this functionality in a separate method, and then in this one, I guess we should just pass the given name of the file and then map the result of this function. So let's see what it will look like. So we will load content of file named, and we should have the file name here as a string. Type we'll have here string, yes, and we should have, say, this, and we should have, of course, file name and type. Good, and then we should complete. Let's see what should be the completion of this function. And the completion of this function, and the most, let's say, high level data structure that we can complete, with this function. I guess it should be data. In the same way, when we load from the server, we have the data represented in bytes, and then we map to what we want. So I guess it is safe to say that we will want to load the data and then we map it to string or maybe any other model. So let's have here the completion, and we'll have the result of data, error, and void. So we can have this of type, I guess here should be a comma, yes, and then we should also complete here with success. And let's see if I guess we should extract data and content of file, and we should build the URL with file URL with path, and we have the file path here, and we should have the URL, and of course this can throw. So let's use result here and try in the same manner we did here up top, and this for the moment should build successfully. Yes, it built successfully, and let's see how can we reuse this here. So here we say load content from file named. In this case it should be source, file path of type JSON, and then the completion. Let's have here the result, and let's go very simple with switch over this result, and we should have, of course, first thing the case success, and we'll have the data like this, and then we'll have the failure error. Let's do first the failure completion. I should have here failure error straight away. So basically we just forward it. We don't do necessarily something specific with this data. Okay, and next we should extract the string from the data, or the filter list. In this case this is the map phase, and we will create the string from data, and we have here data and encoding. It will be for us UTF-8, and then we should complete with success filter list, but it's optional because this extraction can fail in the same way that we could fail previously loading from the file, but previous API throw error, but in this case if this fail it just return nil. So let's guard against it, else, and we should complete with failure. And let's create a failure, something like this, corrupted filter list error, which is very descriptive in this case, that the filter list is in some bogus format that we can't map against. Okay, and let's see if we are good. Let's run our test and see if we fail. No, everything is successful. So as you can see, we did some quite of refactoring here, and our tests guide us that we are still doing the right stuff. I guess I want to believe that we still are doing this. So yes, so far so good. Let's see what we can do further to improve this. One thing we can do is to create an extension over the BundleLoader, and move this code here, and then we can say bundle load, and we should bring this error also here, and maybe we can write this as missing file error and change the name to be more descriptive. Let's run again our test, and we almost are good, because now we don't have bundle to point to. Let's run again, and yes, we are good. Then one more thing that we can do is if we look like here, this is still kind of verbose, and this caselet for the failure, we just get the failure and then forward it. Maybe we can do something like this. We can flat map. We have the data, and then we just have something like this. We have here the return, here also the return, and of course we should wrap this in completion. Let's run our tests and see if we are good. Yes, indeed, everything looks fine. And basically what we are doing here is we flat map our result to another result, and this block will be executed if the result is successful. This one, if it's failure, it will just forward the error. And we can do one more step better here, is let's create a nested func here that we can call like map data or map filter list, say something like this, and we should have here actually a load result. Very nice that we have this type alias and we can reuse it here. And what we should map? We should map data. We will have data and we can bring it here, and we have this function that does exactly this, a very simple thing it does. It maps the data and then we can refactor it to something like this. Map filter list. Let's run our test and see if we are good. Yes, indeed, we are good, and we see how much expressive is this. We previously had a switch statement and so on, much more complicated, and this looks a lot more nicer. And I guess there is one more step that we can do to refactor this, and maybe this will help us later, is that we basically what we want is to transform a completion to another completion. So we have this completion here and we want to transform it to this completion. And yeah, why not? Let's try and see how it will work. So we will want to map, let's call it, what we'll do, we'll want to flat map closure. And what closure we want to map? Let's have here the closure. We'll have something like this, just writing it and see how it would look like. So then we should have here another closure. Let's just sketch this up and see how it will look. And then we should have the fmap function that will map something to something. Yes, good. So let's see then what we will have. So we will change the types. In the first case, we'll have here the result, the data, and in the second case, we have the filter list. So this will be a generic. Let's write here T and O. So we should have something that will map from T to U, something like this. Let's see. Yes, and then we should have here a result. Let's write those and see how those would look like. And maybe first thing first, let's actually get rid of these generics and try with some actual, with concrete parameters and see. Okay, let's write this here. Let's have here data and here result of filter list, because this is what we want to do, and we want this to map from data to result of filter list, because this is what we want to do. And actually I think this should be flipped. Here we have the filter list and here we have the data, and let's return here and we have the data. And what we can do, we can have the closure on which we have the fmap of data. Let's try and build is successful, and let's see what is wrong here. We should have the error, and we can have the same generic error. Good. Let's try and see how will we use this here. We can have the bundle load content of file source file path of type JSON, and here the completion. We should have something that will transform to a different type, and we have this function. As you can see, it takes one closure and then fmap and returns a function that can do this stuff. So here we have to pass the result data error void, and this function will return such an object, such a function, not object. So we can write flatMap, or actually let's do this more shortly, and we have fmap closure to something like this. So we have completion and then map filter list. And let's remove the necessity to provide the name of the argument. And we have something like this. Let's run our code and see. Yes, we have this one. Now let's see where we failed. Yes, we need one more error here. And we can convert to, let's see, what is wrong here. So we have here the data, the fmap, we pass the data, and we cannot convert the result of data error to expected argument data. That's interesting. Let's write here the closure and see. So we will call this closure, and we should pass a result, and we have fmap where we forward the data, which is a result, and this is of course wrong, because we should have actually something like this. We should have the result, and we can have the result flatMap and then fmap, our fmap that we want to use. It's good that Xcode helped us to fix our mistake, and here we should have escaping and this one also. Let's build, and we build it successfully. Let's run and see if it works. Yes, and indeed it works. And again, as you can see, we did a lot of refactoring here, and our tests again help us making sure that it works correctly. And then let's refactor this function to be a generic, I guess TV, something like this. It reads nice, flatMap closure TV. Okay, so then we will have here the T type, and the V1, and here the V1. Yes, let's build and let's run again, and it's all good. And with this function, we can use it anywhere where we will have a completion and we want to map to another completion, as in this case. And then we are working in somewhat point-free style where we don't expand the closure and so on and look into it, but rather we compose the functions, and it reads a lot more nicer. That we transform this closure, the result of this closure, to this one. So we map a completion to completion. It's very nice to have when you have a lot of completions and so on, and you are doing the same again. And it also helps expressing the content of the closure with a function like this, map filter list, which is much more expressive. Good, as we see, we have passed the test, and then we can move one step further and move this to an extension of our BundleLoader, of the bundle. So let's do here extension and have the bundle. remove this, remove this, and of course we had broke a lot of tests. Here let's change make SUT. We can return this straight away. We are good. We can here get the make SUT and put it here. We don't need this anymore, so this is good here, I guess, because we are still accessing the bundle to load from, but we need to rename it to SUT. SUT, we are good. We don't need this, we don't need this. We should have here SUT, SUT, and here, yeah, we can use straight away SUT. And let's run again our tests and see if we broke something. Indeed, we did. Let's see, we should make this public because the protocol is also public. Let's run our tests and all good. Still, again, confirming the fact that tests help us with greatly with the refactoring and moving safely with the refactoring, granted that we have tests. So this is kind of a feeling of the good end design to have for this bundle loader, and we specifically load from the bundle. We have this generic function that will help to load the data for any file, and then we'll have for each use case extension on bundle where we conform to the protocol. And basically here, I guess we'll have like all of the functions like this, and then we'll just pass a map function. Maybe what we can do in future, we will extract yet another function and to which we will just forward the completion to complete and the mapper from the data to the given model. But for the moment, this looks good. I guess one final thing that we should consider fixing is that it doesn't seem right here to use an API on SUT to load the data and then assert again that our SUT loads again correctly. And this is due to the fact that we have added this extension on bundle to load the file and then assert against it. But of course, we should get rid of it because our SUT is bundle itself. So let's for the moment not remove it. We will move step by step. In this case, we should create a custom any filter list locally. And let's create one. Private func any custom filter list, and we should return a filter list. And let's have here one. I guess, yeah, we should return straight away a string, and let's see what is the content of custom any. So this is the content of it. Let's try and get it and bring it here. Of course, it will not work because this is multiple line string, and we should do something like this and have a multi-line string. Yeah, let's see if the indentation is correct. It will help. Xcode will help us with this. Yes, let's see. Yes, and we are good with this, but let's use this any custom filter list now in our test. And let's have it here. Yes, and even here. And let's see what is the difference between our created string and what is in the actual JSON. Let's see here the comparison. And what is the difference between those? We have something like this, and we have something like this. So those are nearly identical, but as you can see, in one case we have something like this and then we have a new line, but in the second case we don't have the new line, and even we have here a space. So let's see. Yes, we have put it here one bogus space. And that's why actually we have talked in previous episode why it's kind of hard a little to have the correct JSON in the string format that will match. And let's see, now we don't have here the space. This looks good, but here we have a new line. And let's see in our expect what we compare first. We have the loaded filter list and the expected filter list. So from the file we have loaded the JSON with a new line, and if you look at the file, we have here a new line, and I don't think we can do anything about it, and maybe then we can just replicate this and have a new line here. Let's see if we are good now. Not, we are still failing. Yes, and now let's take a more deeper look. What is the actual problem? So this part is good, this is good, this is good. We have the new line, but I guess the alignment here is not good. We should shift one more time to the left. Let's try and do this. Will it be good right now? Nope, and still failing. Let's see why. Yeah, this is, as I said, this is problematic to try and get it right. And let's take a look again. What is the actual problem? What is the difference between those two strings? I somehow I'm missing it. And yeah, I think this is the space here that we need one more space. Is it? Yeah, it's indeed very fun to work with this. And nope. Let's see, do we have even one more one? Oh god, this is indeed fun. Nope, we are still failing. Nope, this is not good. Let's try and copy again from the file and see if it will put straight away with a copy paste correctly. Here is what we have. Yeah. I guess I should have done the copy paste straight away and not try and work my way with tabs. Yeah, shame on me. Good. Then we can do the same for others. Let's copy. Here we have one custom filter list, and we should have here for easy list without a and with a, so we can have any easy list and any easy list with AA. So let's go and copy from easy list this part. I guess we have it one more new line. We shouldn't have this, otherwise it will fail. So we have easy list, we are good, and then easy list plus exceptions, and we are good. So let's reuse those, and we should have here any easy list with AA, not like this, but like this, and any easy list without AA. Good, we should be good. I guess, I hope so. At least I hope so. Let's try and build it. And yes, indeed, all good. So we have moved from asserting the content of file that we load from the bundle, and then with the content of file loaded with BundleLoader, to having the content of file expressed directly in code, what we want it to look like, and then to see that we actually load what we want from the file. And of course, one trade-off of this is, as you can see, you should see what is the actual structure of the JSON that we will want to map, and it can be troublesome to get it correctly straight away. And also you will have to keep those in sync. If you change the JSON file, you should also update this, otherwise the test will fail. But the first point is we tackle this right now because we map to string. If we will have mapped to a struct or an enum sum, then we will have that problem. But nevertheless, still you need to keep the encode model with the JSON model in the JSON model in the bundle to be the same. So yes, we are good with this, we are covered. And then one more thing, and the final thing that we can do is to move this code to production. Let's create here a file, and first we'll name the BundleLoader, and we should get this. And for the moment we will keep those two in the same file, the extensions over the bundle. Maybe in the future we'll move them to separate files, but right now this is good. Let's try and build and see what is problematic. Yes, I guess I missed why we have put this public. Yeah, we shall see. And then we'll have here, let's say, functional operators or something like this. Functional helpers. Let's name them like this and put it here. Remove this. Let's build. And I think we had the error because we don't have those in the production. Let's have those in BundleLoader. This, let's build. Let's run our tests. Let's see that everything is good. And actually, we can create a new file called bundle plus bundle filter list loader. Yeah, naming is hard. And then we actually can get this and move it to this file, because we have also a lot of mapping and so on, like the mapping that we do here and also the mapping, and this is very specific to bundle filter list loader. Let's run our tests again and we should be good. So yeah, this is pretty much it, this episode. We had, or at least I had, some struggles with mapping correctly the custom string to the JSON, but yeah, it can happen. At the end of the day, just copy paste helped me. And what we have covered a lot in this episode is mostly refactoring and how tests can help us moving fast and let's say with ease and safely at the same time with the refactoring. So this is one very nice benefit of having tests covering you. So that was it. Thank you for staying till the end of the video. See you next time. Bye bye.